Hi, my name is Alex, and here are some ants. These ants are all mathematically driven. I think of them as Markovian agents, and the memory is actually stored in the actual environment itself. So these are Markovian agents exploring their environment, and you can see them starting to build little defense mechanisms here. And you can also play with different variables and different parts of the script. You can add different uh, layers to the network, and so you can see what's going on. And I've done this with lots of different biological and physical systems. I'm really interested in what happens when variational free energy reduces, and I see it as coherence increasing. That is, coherence as memory density through time. Here we have a mycelium network, and you can see the coherence field there, growth activity, network formation. So all of the scripts are all mathematically driven, using the same formalism, which I'll show you in a moment. Um, Here we can see mycelium network underground, glucose exchange, and moss starting to exchange nutrients in the network there too. And some L system trees up there as well with the photosynthesizing sun. Hurricane. So on my talk, you'll see that that has a higher omega value because it's more in an exploratory campaign. So it's sort of higher temperature. Here we have thunderstorm, and I'll just explain as coherence increases in the cloud as charge, eventually it reaches a rupture threshold, um, and we get thunder and lightning. The sounds from these scripts where their sound is all diegetic from within the script itself. Here we have an atom, and change the electrons, and it will change the obviously the atom that we're looking at. And just to explain that CRR, or coherence rupture regeneration, which is the formalism I'm open using, is a coarse grain formalism. So I'm not saying that this does anything microscopic within paradigms, but it's a good, I find it a helpful way to think between paradigms. So here we have the sun, again, modeled with the CRR. And here again, we're looking at how coherence builds through time, how we reach these rupture thresholds where exploitative campaigns can no longer operate, and we need exploratory new generative model which reweights from the past states of coherence. Here we can see ice and change the temperature, watch ice forming. So I've done basic modeling as well. This one has a lower omega value. It's sort of less exploratory, more rigid as a physical system. And here we can see a hologram. So here we have perturbation of the coherence field. And this is exactly modeled in the script. Um, Here we can see a maze, or sort of rim solver. So the agent is a Markovian agent, and the memory itself is stored in the field, in the environment. So what is CRR, or coherence rupture regeneration? Well, here we have coherence formalism. So coherence is building memory density through time. It's essentially all past states matter in a non-Markovian sense. And we have this Lx tau here, which is how memory density is built through time. Coherence reaches critical thresholds where the environment provides new free energy spikes and can no longer, the exploitative campaign can no longer work. So we require an exploratory campaign or creative campaign. And this is where the rupture or the direct delta leads to a new kind of generative model. And you could think about this as scale invariant, moment to moment, or coherence built through time, and then rupture being like ecosystem collapse or something in the body collapsing, or a psychological shift or an ontological shift through time. Here we have regeneration. So here we have the historical states here, picking up from the coherence of memory density here, and we have a Boltzmann-like regeneration operator. So regeneration is exponentially building on what mattered most in those past states through time. So this is an exploratory playground. So I think of it like a free energy playground, exploring coherence-based approaches. I put various videos on here, explainers, other bits and pieces for people to play and explore. And I'm just looking for people that might be interested in this. So I'm really happy to be part of this symposium, and thank you.